Chapter 1, homework questions 112 to 116. Question 112. Copy the Venn diagram below on your paper, then show where each person described should be represented in the diagram. If a portion of the Venn diagram remains empty, describe the qualities a person would need to belong there. So number 1 studies a lot of class. Number 2 has long hair. So on part A it says, Carol, I rarely study and enjoy braiding my long hair. So since Carol rarely studies, that's not number 1, and she enjoys braiding her long hair, which means part of number 2. So she is only inside circle 2, I guess. So in this part right here, she's not in the intersection, just on the outside, in the inside part of that one. B, Bob. I never do homework, and I have a crew cut. So short hair is a crew cut. Rarely does any homework, so doesn't study a lot for class. So for Bob's case, he's actually outside both circles. All right, and Pedro. I love joining after-school study teams to prepare for tests, and I like being bald. So he doesn't have long hair, but he does enjoy studying. So for Pedro, only inside circle 1. And then the last part says, describe the qualities a person would need to belong in a portion of the Venn diagram that remains empty. So this is the part that remained empty. So that means it has to include both parts of circle 1 and 2, which means they have to study a lot for class and have long hair. And so I believe that answers all of the questions. Question 113. Sandy has a square, equilateral triangle, rhombus, and a regular hexagon in her shape bucket, while Robert has a scalene triangle, kite, isosceles trapezoid, non-special quadrilateral, and obtuse isosceles triangle in his. Sandy will randomly select a shape from her shape bucket, while Robert will randomly select a shape from his. So part A says, who has a greater probability of selecting a quadrilateral? So let's go through and mark what they have. So Sandy has 1, 2, 3, 4 total shapes in her shape bucket. And for a quadrilateral, we have a square and a rhombus. So for Sandy, looks like she has a 2 out of 4 chance, or 1/2 or 50%. Let's see what Robert has. There we go. He has 1, 2, 3, 4, 5 shapes in his shape bucket. And how many are quadrilaterals? We have a triangle, so a kite, an isosceles trapezoid, a non-special quadrilateral, and an obtuse triangle. So he has 3, but he has 5 shapes. So 3/5, which would be 60%. Sandy is at 50%. So therefore, who has the greater probability? That would be Robert. Part B. Who has a greater probability of selecting an equilateral shape? So let's go through and look at each of those. So for Sandy, she has an equilateral triangle. Looks like that's it. So Sandy has 1 out of 4. And then Robert, he has, scalene, kite, isosceles, non-special, and an obtuse isosceles. So it looks like he doesn't have any. So that's a 0 out of 5. So therefore, if Robert can't get any and Sandy can get 1, then she has the better of the probability. And now I take that back because I realized when I went back and looked at her shapes, I was only looking for the word equilateral. Let's go back and reread that myself. So equilateral triangle, but a square also has the same sides in terms of their distance. Rhombus does as well, and so does a regular hexagon. So actually she has a 4 out of 4 chance, which is a 1. So she's guaranteed to actually pick an equilateral shape out of her shape bucket. My apologies, I looked at that too quickly. All right, on part C, what is more likely to happen? Sandy selecting a shape with at least 2 sides that are parallel, Or Robert selecting a shape with at least two sides that are equal. So, read that again. Selecting a shape with at least two sides that are parallel. So a square has two sides that are parallel. A triangle does not. A rhombus has two sides that are parallel. And a regular hexagon would have two sides that are parallel. So Sandy has a 3/4% chance, or chance, and then 75% chance. Whereas Robert, let's take a look at his. Now Robert, we got to make sure we're looking at something different here. Selecting a shape with at least two sides that are equal. So we're looking for equal sides on Robert's. So scalene triangle, that means three different sides, so that's no good. A kite would work. Isosceles means two of the same sides are equal, so that'd be 2. Non-special quadrilateral, so that's a no. And then an obtuse, once again, isosceles. So it looks like he also has 3, but he has 3 out of 5, which would be a 60%. If you're looking at percents here, this would be a 60%, whereas Sandy's would be a 75%. Therefore, Sandy is more likely to select a shape with two sides that are parallel than Robert selecting at least two sides that are equal. Question 114, we're going to solve the equations. Be sure to check your solutions as well. So on part A, we have 3x minus 1 over 4 is equal to negative 5 over 11. So we can get rid of the 11 by multiplying both sides by 11. And then that would give us 11 times 3x minus 1 over 4 is equal to negative 5. And then now we can get rid of the 4 by multiplying both sides by 4. So this would cancel here, leave you with 11 times 3x minus 1, which I'm going to go ahead and distribute. Save me a little bit of time here. To get negative 20, add 11 to the other side, we get 30. 3x is equal to negative 9. Divide by 33, and we can reduce that by 3. So that'd give us negative 3/11. And then as it says, be sure to check your solution. And once again, remember when you check your solution, you're plugging x back into the equation and making sure you get a true statement. All right, next up, B. B, we have two things that are being multiplied to give you 0. This is called the zero product property. And the zero product property states when you multiply two numbers together to get 0, one of the numbers has to be 0. So we will solve this by setting up both factors to be 0. And we'll get two possible solutions here. And so x could equal 5 if you add x to the other side. This one you'd subtract 3 and divide by 2. X is equal to negative 3/2. So there are two solutions, and this is actually a quadratic. It's just factored out for us. So x is equal to negative 3/2, and x is equal to 5. C. Let's go ahead and distribute the negative 5 inside the parentheses. You cannot take 6 minus 5 because it's 5 times the quantity first. So it would be 6 minus 10x plus 15. Negative 5 times negative 3 is a positive. Combine your like terms and get the variable term on the same side. So I'm going to add 10x, and then I'm going to combine the 6 and the 15 to get 21 is equal to 14x plus 7. Subtract the 7. We'll get 14 is equal to 14x divided by 14, and x is equal to 1. And remember, once again, to show that you know that this is the correct answer, you would check your solution by plugging it back in. D, I'm going to go ahead and let's see what we got. I'm going to change the 3/4 to a decimal. I'm not really sure that that's necessary, but we'll do it this way. We'll also subtract 2, so that'll give us 4x minus 3. Then we can subtract the 4x, and that'll be negative 3.25x is equal to negative 3. And divide both sides by negative 3.25, and we'll get x is equal to a decimal, but we'll change it back to a fraction and get 12/3. And I'll show you the other way if you didn't want to change the fraction to a decimal, because in a lot of cases we don't do that. But so let me redo it a different way. Maybe subtract the 4x. You still get the negative 3.25, but we would write it as a fraction, negative 3 1/4 x. Subtract the 2. So it's really the same, you're seeing it, but it's written as a fraction. I'd probably change this mixed number to an improper fraction, so it'd be 13/4, negative 13/4 x is equal to negative 3. Then we could multiply both sides by 4, get negative 13x is equal to negative 12, and then divide by negative 13 to get x equals 12/13. Now, either way is fine, obviously. This one, if you did divide, you're going to get it kind of maybe a nasty decimal. Just make sure you change it back to a fraction so we can get the exact answer. Question 115. When the shapes below are reflected across the given line of reflection, the original shape and the image create a new shape. For each reflection below, name the new shape that is created. So if you reflect this, it would look like that, and you can see that that represents a heart. On the next one, these will still be right angles. This would be a 3, and a 6. So this side is also a 6, so therefore it would represent a square. And we do want to be specific. If we called it a rectangle, it still is, but we want to kind of be as specific as we can. And then if you reflect C, once again, all those sides would be the same in terms of this one and this one being the same. So you got 1, 2, 3, 4, 5, 6 sides, so we're looking at a hexagon. On part D, it says use this method to create your own shape that has reflection symmetry. Add additional lines of symmetry. Note that the dashed lines of the reflection in the figures above become lines of symmetry in the new shape. So obviously just create your own on that one. Question 116. Copy triangle ABC below on graph paper. Rotate triangle ABC 90 degrees counterclockwise about the origin to create your new triangle A prime, B prime, and C prime. Name the coordinates of C prime. So you're going to take the triangle ABC, and remember this is your A, B, and C, and that's from above, up here. And you're going to rotate it counterclockwise 90 degrees about the origin. You always need some point of rotation, so at the origin is where we're going to rotate it. Once again, tracing paper would be a good option at this point. So there you go. You can see the rotation. Also, don't forget it does say name the coordinate of C prime. Reflect triangle ABC for part B across the vertical line x equals 1. So let's go ahead and get in the vertical line x equals 1 since that's where we're going to be reflecting. To create new triangle, A double prime, B double prime, and C double prime, name the coordinates of the vertices. We'll be naming all the coordinates. I'm going to go ahead once again and label the triangle so we know this is A, B, and C. And then now we're just going to reflect it. So this would be B double prime. Right here is C double prime, and then A. So I believe right there. And then that. So here would be your reflection. And then we'll name the coordinates of each of these. A double prime is at 6, 2, it appears. B double prime is at 2, 3. And C double prime is at 5, 6. All right, on to part C. Translate triangle ABC so that A triple prime is at 4, negative 5. Name the coordinates of B triple prime. So we have A, B, C, and A triple prime here is going to be at 4, negative 5. So 1, 2, 3, 4, negative 5 right here. And so we want to see what B double or triple prime would be at. On this one, it doesn't say what translation. Oh, no, it does say. It says translated. Okay, so at first I didn't think it said, but translate it. So that means we want to take A and see how far down we go and how far right. So if we count that, we got 2, 3, 4, 5, 6, 7 units down, and then 1, 2, 3, 4, 5, 6, 7, 8 units over. So we'll take B, we'll go down 7 units and then 8 units over, which would be, I think, right here. And so therefore, B triple prime on this one, if I got that right, looks like it's 8 comma negative 4. So it's translated down 7 over 8, and we did the same thing with point B.